everybody. This is Chuck, and you're listening to the ITXP for October 2025. I think this is the third episode or second episode in the installment of my Going Back to Basics in the audio series. And I wanted to talk about the AWS outage that occurred on October 20th, 2025. Most of us have received information under NDA. I'm not going to get into some of the information in there, but I think for the most part, folks have already understood what the challenges were with the outage and how an outage in US-East-1 impacted the world. First and foremost, I think we all understand that DNS is critical to the way the internet works. And for those that don't understand DNS, it is the service that translates friendly names into numbers, or IP addresses, I should say. And those IP addresses are the servers that host the data that you're trying to get to, a website, a database, any other service you could think of is hidden behind an IP address, right? So DNS is the friendly way to make sure that I want to get to 1.1.1.1 instead of using 1.1.1.1 or remembering that for here on in eternity. You go, I want to go to dns.cloudflare.com. Again, just examples, nothing really definitive there. And most of you who probably aren't used to IT and things like that, you're like, well, I can always remember 1.1.1.1. Yeah, but what about if it's like, 12.152.78.12? And then you have a bunch of other servers behind it. You're not always going to remember those things, especially at the scale of the internet that we deal with today. Even in your internal corporate network. I remember when I first started at a small company, we used, I think, Roman gods as server names and things like that. And those are easy to remember. And that's what we use DNS for. But DNS is critical to the backbone of the internet. Everything relies around the DNS. Now, DNS has been around for a long time, somewhere around 40 years now at this point. And I'm trying to be cautious with my words because I don't want to reveal too much in terms of what was in that NDA, RCA, NDA, whatever you want to call it. But the RCA, the root cause analysis that was sent over under NDA. I don't want to go through that because I think there will be a more consumer version or friendly version of what happened. But it's 2025 and we're still faced with challenges around DNS. And those in the IT field always laugh. It's either the network or it's DNS. Those are pretty much two issues that if anything goes wrong, check the network, check DNS, or check DNS, then check the network. We joke about it, but it's relative in this case. And one of the things that people often ask me is like, Chuck, why is this DNS issue still a problem in 2025? I think firstly, you have to understand the scale at which Amazon works, the scale at which all these large providers work. Traditional DNS, in the sense of whether you're running a bind server, whether you're running Microsoft DNS, whether you're running Infoblocks, whether you're running any of the, I'm going to call them enterprise DNS systems, they're good for your enterprise. They do just a good enough job. Obviously, the more mature platforms like Infoblocks offer a lot more functionality. You can build regional rules for ensuring that if your traffic hits a DNS server in your Asia Pacific area, it's only going to go to servers in that area. Why come back all the way to Europe or the United States? It doesn't make sense, right? You have a little bit more flexibility. Microsoft also offered some of that in Microsoft DNS with regional pools and things like that. So there's some functionality that you can do in DNS, in enterprise DNS, that just makes sense. Then Amazon comes along and says, hey, we need to do DNS at scale. We need to do DNS at scale. How do we do this? This is going to be interesting. So they decided to leverage one of their services like DynamoDB to maintain these records, right? These DNS records, like hundreds and thousands of DNS records across each fleet. And they've enabled automation around that to manage those records and things like that. They have things in there to look at the management of those records, look at failure mitigation, right? When things are going across multiple zones, things like that. There's resiliency in there and things like that. And there's just a lot going on when you're working with DNS at that scale, right? Think about it. Think of all the services that AWS runs. Hell, think of all the services that all the cloud providers run. There are services in where you need a consistent record. There are services that you need ephemeral records. So for those that don't know, ephemeral records are short-lived. Think of Kubernetes instances, right? And you spin up a container. It has an address on it. It does what it needs to do, then shuts down and goes away forever. So DNS at scale is something that not many of us in the industry have worked on. I think in my organization, maybe we have 100,000 records. I haven't looked because I honestly haven't even had a reason to care because I'm outside of that scope of responsibility at this point. But when you're working at scale like that and managing hundreds of thousands of records, it can be daunting. And finally coming up with a way to do that is key. And automation is going to be a big role in there, right? Because it has to, because you have ephemeral records, you have static records, you have records that could change because you're moving to one region to another. You have to make sure all that stuff is kept up to date and managed, and they're doing it using their DynamoDB service. Now, I don't know when they started to implement that. This is not a history lesson on how Amazon built out their DNS service, but they have a bunch of different services within DNS, right? To be able to manage those records, right? And those are things that coordinate and orchestrate. And again, I'm pausing because as I'm reading through this document to pick out some key notes, I want to make sure I don't want to divulge too much under this NDA. So there are other backend services that coordinate and manage the updating of records on Route 53 and so on and so forth, right? So as a background, when you do DNS at scale, at least in the AWS side of the house, they leverage this service called DynamoDB. And then what happened was that at some point during the night, there was a race condition that occurred between two of those backend services. And because of that issue, everything else, it was this cascading effect for everything else that ran, right? So there was a race event. Two things tried to occur at the same time. Some processes were falling behind. And during the cleanup process, one service didn't know whether it was the source of truth or not, and it started deleting things. In a nutshell, that's kind of what happened, right? And they started repairing things and things like that, and they started dealing with API issues and things like that because of DNS. And you sit here and you think, damn, for all the years that we've been dealing with DNS, right? A backend issue like a DynamoDB service hitting a race condition takes out, what was it, 50% of the internet, something like that. And you sit here and you're like, well, guys, DNS is DNS. Why is this such a problem? And I know people are asking that. I know people continue to ask that. They're like, hey, why is this still such an issue? And again, it really goes back to that concept of, well, you're not doing it at scale, so it's really not that easy, right? So it's not that easy. There's things in the background that that work to manage things like EC2 instances, in terms of network manager, availability zone management, things like that. There's state checks that occur that all depend on this DynamoDB table, right? And if that breaks, then boom, you're done. And then you start to think, well, why wasn't there redundancy in the DynamoDB table? And that's where I think, right, I think as we go forward into this kind of RCA, you start asking these questions, right? And they're like, well, why isn't there redundancy on this DynamoDB table? Because if you have backend services that are tripping over each other, that then cascade to other services like EC2 instances being built, and then network load balancers relying on those EC2 instances, but they couldn't connect to it because they didn't know what the DNS name was for it, or FQDN for it, fully qualified domain name for it was available, right? You're looking at this compounding effect, right? Where you're like, but why doesn't DynamoDB have resiliency? Like, again, like why? Like why is it this one DynamoDB table or service just it shit the bed, and excuse my language, but it shit the bed and just doesn't do that? Like, I don't understand that, right? Like, I just get it, and I don't think they even covered it. I'm looking through it again. I don't even think they covered that aspect, right? And if I look at DynamoDB, let me pull it up real quick. Actually, I'm going to ask AI because it's easier. Like the service in of itself should be resilient, right? Is AWS DynamoDB resilient, and how? So if I think about how DynamoDB is architected, right, I'm thinking of a big database, right? So DynamoDB automatically replicates data across multiple availability zones within a region, typically 3. Data is written to multiple storage nodes before a write is acknowledged as successful. And then if a node fails, DynamoDB automatically routes requests to healthy nodes. So think about this, right? So if a node fails, DynamoDB automatically routes requests to healthy nodes. Now, my next question is, well, how does it do that? How does it do that, right? And when you think about that, you wonder, well, it does it through API, right? It does it through API. And then what other service does it use when it needs to do a failover? It needs DNS, right? It needs DNS. So I'm asking, is DNS involved in this failover process? And so obviously you have APIs, and it says no, DNS is not involved in this DynamoDB's node level failure, right? So your application resolves it's talking about the front end interface, right? So it's not talking about what happens internally. So again, I don't want to go down the rabbit hole with DynamoDB, but the challenge was, right, so they had a race condition in the DynamoDB backend services that manage the hundreds of thousands of records within the various Route 53 zones that are hosted across the hundreds of services that they offer. And it's like a new service every other day, it seems like. So that race condition triggered other back-end services to fail, then therefore started causing unknown, what am I looking for? Golden source of truth for the DNS entries, right? Whether those IP addresses are valid or not and things like that. So it didn't have a way to manage the amount of information that's coming in into the service. So if you think about the API calls, right, there are a lot of latencies that started to build up because There was a lot of uncertainty in DNS and things like that. So it just started compiling. Think of it as like an avalanche of events. One little pebble cause an avalanche of shit. And if you look at an avalanche as it flows downhill, all the stuff from the top comes down and just crushes everything. And that's essentially what happened, right? At a high level. Again, I'm not going to go down to nitty gritty because it is under our RCA, NDA. But we sit here and we think about, well, if they're managing DNS, leveraging DynamoDB, and they ran into a problem, how do we ensure that we, as an organization, mitigate any potential issues with a service that we rely on so much? And if you follow my TikTok, I did a 3-part series throughout the day on this outage, but I'll talk through it here as well. When we were tasked with cost optimization efforts for our security team. Now, to remind you, I'm currently working on the cloud infrastructure side of the house, focusing primarily on building out the cloud platform landing zones so the businesses can leverage those platforms for their use. We don't work with the application teams. We effectively just build the landing zones with our guardrails, with the security team, setting policies and executing those policies. And then when a line of business wants to host an application in one of the cloud providers, they ask us for a subscription account or project, depending on the platform that they use. And then they effectively have full reign within that subscription account or project. With some guardrails, right? There's a couple different, what's the word I'm looking for? There are a couple different scenarios that I'm thinking about where we play a role, and it depends on whether or not the application team or the business unit have a dedicated team to support it, and we may come in there and play a supporting role as well. So that's kind of the background of where I am. Your situation may be different. In your situation, you may be looking at us like, wow, I would love to be in that space. Yeah, I'm not going to lie. It's a pretty good space because I don't have to do releases and things like that. But when things like this occur, there's more scrutiny on us and ensuring that we're doing everything we can to mitigate outages like this. And I'm reminded that last year, about 13 months ago, a bunch of us were in Colorado talking through a new solution that would help decrease our overall costs for firewalls. Because think about it. If we're doing on-prem, if we're doing 3 different cloud providers, and then we're going through acquisitions, right now, the way the security team does things is they kind of deploy firewalls all over the place. And the security team loves using those good old Palo Altos, those good old expensive Palo Altos. And it's become unwieldy at this point. It's very costly, and we needed a solution to start thinking about how we can reduce that footprint, right? Not only because it's costly, but because it really, think about it, it exposes us to some risk, right? As you spread out these Palo Altos, yes, they're security devices, but if there's a vulnerability in one of those firmwares or those operating systems, and you got to patch them, there's just more to patch. So what we want to do is to decrease the footprint. The business case for this was also that we would then be able to enable the business to be able to leverage that solution to become truly multi-cloud. Now, obviously, the business had to refactor their applications to take advantage of this service, but it would truly make them multi-cloud, and it would minimize the dependency on one cloud provider. So in this case, maybe, based on our proposed design, if we had our core revenue generating applications behind this solution, it would have picked up the outage in AWS and continued just working in one of the other two cloud platforms, whether it be Azure or Oracle or Alibaba or GCP, whatever, right? And that was the proposal, right? But what happened was, we as infrastructure folks and security folks went about it the wrong way. We went about it as an overall cost savings in the long term, but when we actually put the numbers together and talked about things like direct connect and interconnects and things like that, those services in and of themselves are expensive. And if you look at Microsoft, I think a Microsoft interconnect, I think it's a direct connect. Microsoft itself is I think a 10 gig circuit was like $100,000 a month. So that raised eyebrows for our technology leadership team. They're like, I don't see the benefit of doing this. You're telling me you're going to save money on the Palo side, but we're going to increase our cost on the cloud side, because it was $100,000 for Microsoft, I think $50,000 for this other cloud platform, and maybe $30,000 for AWS. I can't remember the numbers off the top of my head, but it was something like that. It was astronomical, and those are monthly costs. And we were working with a partner, a vendor partner, and things like that. And we were trying to really crunch numbers as best we could. And when we presented it to the leadership team, the technology leadership team, they're like, guys, this is not really saving us any money. And I also pitched my thought about, well, we're enabling the business, blah, blah, blah. And then they're like, well, do you have any stakeholders that are agreeing to this? And we're like, yeah, we have one, definitely. Two is on the fence about it. And then we'll approach the other ones to see if they want to do this. And I should have been clued in last year when they said this, and I just didn't really put two and two together because there were so many other things going on. But as I reflect now after this outage, and I even told my leadership team, I was like, I think we went with the wrong approach with this solution. We approached it as a cost savings effort as opposed to a business enablement effort. And we should have partnered with the business a lot more and a lot sooner to really see what's going on. And I'm talking about across the entire enterprise, not just the few key stakeholders that we knew would be friendly to this initiative. And I think that sometimes as infrastructure folks, we tend to forget, or maybe we overlook. I wouldn't say we forget. We tend to overlook that value of partnering with the business to do some of this work. To ask them, say, if we build this, how long would it take for you to refactor your applications and move to true multi-cloud? And the reason why that's key is because you'll learn that some of them will never be able to do it because they don't have the skill set in the other cloud provider and things like that. And I kind of regret not really seeing that early on. And this is one of the things that as you move into a leadership role, you have to have that insight and forethought to really anticipate the business needs, but also anticipate the business challenges when you offer a new solution that they may not be ready for. And that's key. We can build the greatest data centers in the world. If nobody uses them because they don't know how to, then that's a failure on our part to anticipate the business needs. So as we continue down this path of evaluating the outage for AWS and evaluating how we move forward from this and working with the business and understanding their pain points through this, we have to take that approach of, well, if we do this, and let's say we do this in 26, let's do this in 27, but the business isn't really going to be ready to do this until 28 or 29. So we've built something that is just sitting there doing nothing. And we're not really taking advantage of it. And that's where I feel like I dropped the ball because I didn't anticipate that. Because I was so hyped up and I was like, yes, this is going to be awesome. It's going to be a service that people will love. And it's that mindset of if you build it, they will come. And that mindset is very, very dangerous because if you don't build a solid service, right? And people let's say you build a solid service and nobody comes because they just don't have the time to refactor their applications, then why the hell did you spend X amount of millions of dollars to do it? Only to save. If I'm going to spend $10 million to save $2 million, I'm still spending $8 million. So lessons learned for that. And I think it's a good testament for those that are in this industry to really think about how you transition your skills from that of a techie to that of a more of a business analyst. Because as AI comes into play some more, you're going to find yourself having these deep conversations with your team. And sorry for the microphone move, with your team or leadership around, well, how do we continue driving the business forward? Because technology is an enabler for the business. We all must remember that. Technology is an enabler for the business. You're not a techie, right? Just kind of living in the techie land. You're sitting there on your Debian box, just coding away. And you know how I threw distro wars there. So you're sitting on your Debian box and kind of working away and things like that. But ultimately, you're doing it to support the business strategic objectives and goals. You're not just there for the pure fun of it, right? You're there to ensure that you're driving the needle forward for the business. And a lot of people tend to forget that, especially in the technology space. Especially those that don't work with application development teams. So I think this was a good testament from the AWS outage to really rethink about how we manage resiliency and redundancy across the organization, especially in the cloud. I said in one of my TikToks, we as infrastructure folks collectively have been doing this at least 40 years, and we know what we're doing. We sometimes get in our own way, as one of my direct reports tells me, and we have to stop thinking like traditional or enterprise IT and start thinking more about application developers and things like that. I know a lot of you go like, I don't want to code. But what are we doing now with AI? AI is coding for us. AI is writing the automations for us. You're telling it. You're talking to AI. You're giving it examples. You're explaining what you want. You're reviewing those outputs, and you're testing. Hopefully you're testing those outputs in a lab environment. So while you're not going to be always coding, you're going to be the one guiding the AI to output. Remember, AI is now a digital worker for you. So AI is going to, take what you put some logic behind it, maybe some reasoning, and then boom, output what you want, and you review it and you test it until you trained a model to do what you need to do. And I think that's going to be key for all of us in this industry to think about how we continue moving forward, especially in the age of AI and some of these outages. AI didn't fix this outage, right? It was people fixing this outage. And that's going to be constant for the next 5 years. So the next 5 years, you're going to be on the phone troubleshooting something that AI probably messed up. And as much as you hate that, just think about that, at some point of our career, we've messed up too. But now it's going to be AI messing it up at scale because we're going to deploy all these digital workers. And now you have to troubleshoot a lot of the stuff that they're working on and that they're doing. So think about that, right? Think about how you can transition those skill sets that you have today into something that, well, AWS had this outage. How could I have played a role in that to mitigate some of these things. Right? What happened with that race condition? I don't know. But in the future, if it happens again, am I going to tell AI to watch out for that? Am I going to do that? Right? Those are the things that should be discussed in your mind to think about what needs to be done to move the needle forward and to remain relevant. Because the future is definitely AI. I'm going to tell you that right now. The future is definitely AI. It's how you respond to that AI transformation. Yeah. Transformation. To be relevant. And that's key, right? How to remain relevant in an age of AI and young folks. So it's a short episode this week because I just wanted to touch base on the AWS outage. But follow me on TikTok, the.it.xp, and we'll continue talking. I'll see you next time. Thank you so much.